Okay, welcome to the video for sections 8.6 on cars and 8.7 on the cost of home ownership. So this video and PowerPoint will contain the information for both sections 8.6 and 8.7 because largely the material is connected. The loan payment formula for fixed installment loans, which a loan that you pay off with weekly or monthly payments is called an installment loan. And so regular monthly payments would be a fixed installment loan. We also have this formula on your finance formula sheet. It is number 9. PMT here stands for the payment amount. P is the loan. R, rate in number of times per year that the interest is taken, and T is the number of years. One big difference in this formula compared to the others that we have seen is in the denominator, that exponent has a negative on the end. So make sure that when you go to calculate, you include that negative in the exponent there. It is negative nt, not just nt like we have seen before. Okay. So as an example, suppose that you decide to borrow $20,000 for a new car. You can select one of the following loans, each requiring regular monthly payments. You can get an installment loan of 3 years at 7%, or an installment loan for 5 years at 9%. So they're going to give you longer to pay it off, but that means that you're going to have to give them a higher interest rate. So we want to know what is your monthly payment going to be, and then also what is your interest amount going to be for each loan, so that we can compare and see which of these loans is actually going to be better for us. So we'll start off by doing the payments. So we'll plug into that payment formula, and we have P, the amount of the loan is $20,000, and that multiplies by R over N. For A, that is loan A, the rate was 7%, so 0.07 over, it is going to be 12 because it is monthly payments. And then over bracket 1 minus parentheses 1 plus that R over N raised to the negative N times T. So N was 12, and T for this one is 3. So negative 12 times 3, 36. And close our brackets. So this is the formula that we need to plug into our calculator. So let's do that. Okay, so 20,000 is multiplying R over N, and that is all dividing by bracket 1 minus parenthesis 1 plus 0.07 over 12. Close the parentheses, raise to negative. You must use the negative symbol down here at the bottom by the enter. Negative n times t, which was 36. And we just need to close the bracket. So I will press to the right, close, and enter. We end up with $617.54. I'm going to go ahead and round this up to the dollar. So we have 618. Okay, so the monthly payments for A is 618. Just put that down there as a reminder. And then we want to know the total interest for loan A. Well, the total interest is going to be formula number 11. So formula number 11 on our reference sheet says the total interest equals the payments total minus the loan total. So we know the loan already, it's $20,000, and the payments are $618 every month. So 618 times 12 months would be for a year. And for loan A, we're doing this for 3 years, so we're going to multiply by 3. And when you put that into your calculator, you get 22,248. So this is the payments amount. So 22,248 minus the 20,000 is $2,248. So that is the amount of interest that we end up paying for this loan. So $618 a month, but over the course of the 3 years, over 2,000 of that goes towards interest and not the actual car amount. So now let's do the same thing for loan B. I would recommend that you pause the video and try loan B on your own, and then restart the video and check your work. So for loan B, payment equals P, 20,000, times the R over N over bracket 1 minus parenthesis 1 plus R over N, all to the negative N times T. Well, now T has changed to 5 years. So 5 times 12 is 60. And I need to plug this into my calculator. So 20,000 times 0.09 over 12 bracket 1 minus parentheses plus 0.09 over 12 raised to the negative 60. And we get $415 as our monthly payment. Okay, so 415, whereas A was 618. So our monthly payments have gone down over $200 by extending the loan for 2 more years. But in the course of the things, we're going to end up paying more money, as we'll see in comparing the interest. So the interest for loan A was, again, $2,248. So now let's calculate it for the loan B. So we have the interest equals all the payments minus the loan amount. That is formula number 11 again. So subtract 20,000 for the loan, and if we pay $415 for 12 months, that gets us 1 year. But we're doing this for 5 years. So we multiply that, and we end up with $24,900. And when you subtract, you get 4,900. So although our payments are $200 cheaper, in the end, we end up paying more than $2,000 extra dollars on loan B compared to loan A. So when you are considering which loans to take, you have to balance out, is it more important for you to have lower payments per month? Or do you want to make sure that you aren't paying too much in the end overall? And for some people, at some points, this loan B might be the better choice, even though you do pay more in the end. It might be nice for you to only have 415 versus 618. Maybe 618 is just too much and 415 is not. So you will need to make those considerations, but you need to understand how it accumulates in the end. If you can afford the 618, then you're going to save yourself $2,652 by paying more upfront so that you have lower interest rate for less amount of time. Okay. Suppose that you're thinking about buying a car and have narrowed down your choices to 2 options. We have a new car option and a used car option. The new car is $25,000 and can be financed with a 4-year loan at 7.9% interest. The used car is a 3-year-old model of the same car, but it is only $14,000, and you can get it with a 4-year loan as well at 8.45% interest. So we want to know what is the difference in monthly payments between the new car and the used car. So we'll plug this into our payments formula. So for the new payment, we have P, the value of the loan is 25,000 times R over N. And in here is monthly payment, so 12 months in a year. Over bracket 1 minus parentheses 1 plus R over N, raised to the negative N times T. T for both of these is 4 years for the loan. So we have negative 4 times 12, 48. Close bracket. For the used payment, we have 14,000 for our P times our rate over our N, bracket 1 minus parentheses 1 plus R over N, still raised to negative N times T. N and T are the same here, so negative 48. Close our bracket and plug these into the calculator. Let's go ahead, and before we do that, we can just quickly compare the formulas and what's happening. On the new payment side, the 25,000 is larger and it's multiplying. So that'll get us a larger payment for the new, but the rate is larger on the used car. So that's going to balance out some. So we can't really be sure which one's going to be greater. There is a breaking point at which one is going to overtake the other. So we'll have to plug it into our calculator and see how the numbers pan out. Okay, so 5,000 times 0.079 over 12 divided by 1 minus parentheses 1 plus 0.079 over 12, all raised to the negative 48. Down and close, and it comes out to be 609. That is the payment for the new car. So we'll plug in for the used car, 14,000. Now the rate is 0.0845. 1 minus parentheses 1 plus the rate 0.0845 over N, and that is raised still to negative 48. Go down, close it, and 344.75, so we'll round up to 345. All right. So the difference in the monthly payments, the new car was 609. The used car was 345. So the difference means subtract. So 609 minus 345, $264 difference. Even though the rate was a little higher for the used car, since it was significantly cheaper, the monthly payments ended up being significantly less. So one thing to keep in mind is uh, even though it's just 3 years older, it's significantly cheaper. You're going to save a lot of money overall. We could also calculate the interest, and you're going to, even though it's 8.45%, you're paying that percentage on much less of a loan. So your interest is going to be less too. Okay. A few different things that we could talk about with cars. One thing is the insurance that you'll need to have on the car. You're going to have maintenance. So if you break down, you're going to have repairs. You might have flat tires. There are parking fees, license and registration. You have to pay taxes. You will have to clean the car. So there's a lot of other things. The one that we're going to focus on is gas. Gasoline is, over the course of time, a huge expense. You might not realize it when you just fill up once a week or whatever. Each time it's not that much, but over the course of a year, it adds up. So we want to consider how much money are we paying for gasoline. Well, at the bottom of this slide here, we have annual costs for averages on different types of vehicles. So you can see that for a small sedan, which is the cheapest for gasoline, it still ends up being roughly $6,700 a year. That's based on driving 15,000 miles. Maybe you don't drive that much. Maybe you drive more. But this gives you an idea of, okay, it could cost quite a bit. So we want to factor that in, because if we can minimize the amount of money we pay in gas, that's going to be money that we could put towards buying a better car or buying something else that we'd like. So in order to calculate the annual cost of your gasoline, we're going to use this formula here. So the formula is included on your formula sheet. It is number 10. And it says that the annual fuel expense equals the miles you drive in a year divided by the miles per gallon that the car gets, multiplied by the price per gallon. Now, the price per gallon can vary throughout the year, but you can pretty much estimate a good average. And then the annual miles driven, you might not know in advance, but you can have a rough estimate of how many you will. And then miles per gallon is given to you when you go to buy a car. You can find that information. It is available on the company's website. And if the car dealer doesn't have it, if you go to a used dealer, they might not know offhand, but you can always access that information. Suppose that you drive 24,000 miles per year and gas averages $4 per gallon. What will you save in annual fuel expenses by owning a hybrid car averaging 50 miles per gallon rather than an SUV averaging 12 miles per gallon? Okay, let's go ahead and calculate this part. So the hybrid, 50 miles per gallon. Well, miles per gallon goes on the bottom of that equation. So we have annual fuel expense, which is the cost, equals the number of miles driven. Okay, it says 24,000 is what we're going to estimate, over the miles per gallon multiplied by the price per gallon, which they save $4. And when you multiply that out in the calculator, it's $1,920. And for the SUV, we have 24,000 still, but now the miles per gallon is only 12. Cost per gallon is still 4. So when you multiply that out, it is $8,000. So significant difference by driving a hybrid that has much higher miles per gallon. You save 8,000 minus 1920, which is 6,080. So you're going to save $6,000 in gas. So it might be significantly cheaper to buy that hybrid, even if the hybrid costs a little bit more money than the SUV. You can offset that cost with the amount of money that you're saving on the gasoline. Okay, B. If you deposit your monthly fuel savings at the end of each month into an annuity that pays 7.3% compounded monthly, how much will you save at the end of 6 years? Okay, so into an annuity. Well, I want to know what formula I'm dealing with. Annuities, well, that was back in section 8.5. The annuity is going to be number 6 on our formula sheet. It's the value of an annuity. So we'll use that formula. A equals P. And here we don't know our P. The P is the amount that we're depositing every month. So if we save 6,080 for the year and we divide that up across the year, we're going to divide by 12, and that would be $507 that we could deposit a month. So since we are depositing at the end of each month, we're going to have to divide that total up. So the amount we deposit is 507. Okay. Then that multiplies by bracket parentheses 1 plus the rate, which they give us 7.3 over n, which is 12 because it's monthly, raised to the nt. They said 6 years, So N is 12 times 6. We could do 72, but I'll just leave it like that. Minus 1, close bracket. All over R over N. Okay, so a little review of 8.5 here. We'll go ahead and I'll let you plug that into your calculator, and you should get 45,634. If you aren't able to get that, then I would recommend that you send me a quick email. We can talk about what you're doing on your calculator to not get it correct. So the section 8.6 on cars includes a lot more information on insurance and on leasing a car versus purchasing a car outright. So I would recommend that if you don't already know the advantages and disadvantages of leasing a car, that you read through that information. It's good to know, but it is not on the test. So we will go ahead and continue. This begins the information for 8.7, which is on home ownership. And reason that we're doing it all together is that it's the same exact formula. Mortgages work the same way as a car loan, so we'll do it here. A mortgage is a long-term loan for buying a house. You can get 15-year loan, 30-year loan. Those are mortgages. The down payment is the amount of money that you put up front that you have to pay before you can say, okay, I'm able to buy this house. I want to show you that I'm able, so here is a percentage of it up front. To find the down payment, it is a percent. Okay, percent of the total. So this is like a question that you would have dealt with at the beginning of chapter 8, just finding a percent of the total. So you might have to find a down payment is going to be 20%. So what is 20% of, if the loan is $100,000? So you're going to have to put 20% up front for the down payment. So 20% of the total 100,000. So change it to a decimal. Of means to multiply. So 0.2 times 100,000 would give you the amount that you would have to pay up front. It happens to be $20,000. So down payments can be significant chunks of money. And this is money that doesn't go into the amount of loan because you're going to pay it before you take the loan. So you would say, okay, here's 20,000, but I'm going to take the remainder of the 100,000 as a loan. So your loan is not the cost of your house. It's the cost of the house minus the down payment that you put up before the loan. Okay. Which is what the next line says. The amount of the mortgage is the difference between the sell price and the down payment. The other items we're not going to focus on. Fixed rate mortgages just mean that you have the same monthly payment. Variable rate or adjustable rate mortgages, they change from time to time. The problems that we're going to consider are fixed rate mortgages. When you go to purchase a home, most lenders will allow you to pay points. And what the points do is it lowers the percentage of the interest rate. So you pay 1% of the loan, and it will lower your interest rate percentage. So by doing that, you could save money in the end, because that lower interest rate percentage will save you more than the cost of buying the point. The actual values you would have to discuss with the lender at the time you're purchasing. Let's see. The truth in lending disclosure shows the buyer the APR. That's the annual percentage rate for the mortgage. The escrow account, usually the down payment and the closing costs will go through an escrow account that just secures the money until it is time to finally close. Okay. Like I said, the loan payment formula for cars is the same one here for homes. So we're dealing with the same formula as last time. It's the number 9 on the reference sheet. Okay. An example. So we have here a price of a home is $195,000. Bank requires a 10% down payment and 2 points at the time of closing. Cost of the home is financed with a 30-year fixed rate mortgage at 7.5%. Find the required down payment. So you have to put 10% down. That is 10% of the entire cost, $195,000. Change 10% to a decimal. Of means to multiply. So 0.1 times 195,000, which is $19,500. So you'd put that down first before the mortgage amount. So the 195,000, you then, okay, give me a second. It's acting up again. Subtract the 19,500 and you're left with $175,500. So that is the actual amount that you would have to take out as a mortgage loan. So you take the sell price, the $195,000 minus the down payment, and that gets you the amount of the mortgage. How much must be paid for the 2 points at closing? So if you're getting 2 points, they said each point is 1% of the loan. So we're going to do what is 2% of the loan. Well, the loan is the $175,500. So change that to decimal. Of means multiply 175,500, and calculator says that's $3,510. So you will have to consider is that amount of points going to make that great of a difference that paying the $3,510 now is worth it to you over the course of the entire loan. Part D, find the monthly payment excluding escrow, taxes, and insurance. So all those closing costs that the company makes you pay, like inspections and the home insurance and property tax and all of that stuff, we're going to exclude from our consideration. So we use formula number 9. The payment is going to equal the amount of the loan, 175,500 times R, which is 7.5%, over N. That's all over 1 minus parentheses 1 plus R over N raised to the negative N times T. So N is 12 monthly, and then T here is, it's a 30-year loan, so times 30. So we'll plug this into our calculator. Okay, so we had 175,500 times 0.075 over 12. All of that is dividing by bracket 1 minus parentheses 1 plus 0.075 over 12. Close my parentheses. That is raised to the negative N times T. Get out of the exponent and close my bracket. $1,227.12. We'll go ahead, round it to the nearest dollar, since that is what the MyMathLab is going to do. So the monthly payment, again, was $1,227. And so find the total interest paid over 30 years. Well, the total interest is total interest equals formula number 11. Total payments minus the loan amount. Our loan, again, was 175,500. So we need to figure out how much do we end up paying all total. Well, we're paying 1,227 every time. So we do that every month for 12 months, and that's 1 year. Then we do that for 30 years, so times 30. So that is the total of our payments, and that's going to subtract 175,500. We could plug all of that into our calculator, or we could do just the payments first. If we did that, the payments ends up being $441,720. That is a lot of money. So that's why you might hear the expression that home is the largest purchase that most people will ever make. Because in the end, for a 30-year loan, you're going to end up paying here about $440,000. If I subtract that 175,500, it ends up being $266,200. That is the total amount of interest that you're going to pay on that home. So you go in looking at $195,000 house, you're actually going to end up paying more on the interest than the house was actually priced at. So don't go thinking, oh, it's a $200,000 house. Well, is it really? If the loan is going to end up costing you $441,000, maybe you should think about the finances a little differently than that. Okay. The section 8.7 also includes a lot of additional information about purchasing a home that will not appear on your test. It discusses the benefits of renting versus buying, and also how much a person can afford in home payments compared to their income. They suggest that your house payment be no more than 28% of the total amount of income you have to spend every month, so that you have enough for everything else that you're going to need. There are very good reasons to buy a home, but there are some good reasons to rent and some downsides to buying. So if you have not fully considered what you might do in the future, I would highly recommend that you read over the rest of that information. Beyond that, that is all we have for you in 8.6 and 7. Make sure that you are able to use all of these formulas. You'll have the formula sheet. You should keep that by your side, but make sure you can use them. If you have any questions, concerns, please email me. We can set up a Zoom if you want, or I can respond back and forth with email. Until next time, hope you guys are doing well.